Okay, so solving for theta is when we go from angle to ratio. Okay, so we have, from ratio to angle, and we use the second sine, second cos, second tan, or the inverse tan, inverse cos, inverse tan, the inverse sine, inverse cos, inverse tan. Okay, or the inverse function. We need to undo the ratio calculation. So solving for theta, we start with ratio. Okay, so we're starting with ratio. Okay, so we're starting with the ratio 1/2, and we want to figure out the angle. Okay, so when I look at this ratio of 1/2, 1 to 2, this happens to be a special triangle. Okay, but when I do this, notice that there are actually two positions that give me a vertical of 1 and a radius of 2. There's two different quadrants where the sign is positive. Because remember, sine goes with y, and sine is positive in both of those quadrants. So there's actually two positions I have to account for. Okay. Now, although this is a special angle, we'll do this like it wasn't a special angle. We're gonna use our calculator. We're gonna use our calculator to figure out the arc sine, okay, or the angle. So we're gonna write it like this. So the inverse sine or the arc sine, the input is a ratio, the output is the angle. And when I put it into my calculator, I get an angle of, the angle equals 30 degrees, which is perfectly fine. And 30 degrees is definitely the angle that I'm looking for. The problem is, there is another angle over here. Okay, so in my class, what we'll do is, when I refer to theta 1, the theta 1 is the angle that we get from the calculator. And notice that the calculator only gives you one answer. Okay, but there are two answers involved in here, and you only get one. You have to figure out the other answer. We have to figure out the location of that point as an angle based on symmetry, because we know that these two triangles are the same triangle. Okay, there's some symmetry here, and we know that the angle here is going to match the theta 1 angle here. So this is going to be theta 1 here. So if I start at 180 degrees and I go backwards theta 1, or minus, I will get the other angle, which I'm going to call theta 2. So there's always two possibilities, because the sign, positive sign, since it's only giving you two sides, it could appear either in this quadrant or this quadrant. Okay, and we don't know. So if we don't know, if the quadrant is not specified, we have to give both answers. So the location of that second angle then must be 150 degrees. Okay, so we can work that out by just using the symmetry of the diagram to figure out if this is 30, this is 30, that must be 150 degrees. There is also a formula. In fact, what I've highlighted in green here, this is a formula to find the second angle for sine. And these are distinct angles, so as opposed to the coterminal angles that we had dealt with before, where we had two different angles that gave us the same position. These are different positions. When we have a ratio, there are two different positions that it can occupy. And if we don't know the quadrant, we have to give both answers. If for some reason the quadrant is known, then we have to choose between the two answers. Okay, so it's really important that you understand that there are always two possibilities when we're solving for angles, and sometimes we'll give both answers, sometimes you'll choose one of those two answers. Okay, so why do we need to worry about two possible solutions in a circle? It's because the circle has folding symmetry. Okay, and when we talk about a ratio, the ratios of sine and cos only refer to one of the axes. Well, maybe I'll write it this way. Refer to only x or y, not both. Therefore, we cannot we can cut out half the circle, but we can't focus into one. We can't be able to necessarily narrow it to one quadrant. Okay, so because sine and cos only relate to sine relates to y, we don't know if the x is negative or positive. So we have to give both solutions. So why did we never worry about this theta 2 before? Well, in triangles, the theta 2 is not a problem, okay? Because theta 2 doesn't exist. Because the triangle can only add up to 180 degrees. Triangle has only 180 degrees. Okay, so if we let one of the angles be 30 and the other one be 150, well, the third angle has to be 90. Remember, we're dealing with a right triangle. This angle is impossible. Okay, it only appears because of the symmetry of the circle. The triangle doesn't have some symmetry to it, so we only have to worry about this when we start talking about standard position trig and we start dealing with angles in a circle. So this is why we've never worked with this theta 2 before. We just kind of assumed the calculator gave us the right answer because we didn't have to worry about different positions. And one thing that's important to know is that your calculator actually is understanding everything that you give it is standard position. Okay, we only gave it positive before, so we only worried about quadrant 1. But now, if you gave it negatives, your calculator will understand that you're talking about a negative positioning.